All right, boys and girls, we're going to go over your Google form for your Thursday, Friday lesson, and it'll make it so much easier for you. The directions say to study the graph and talk it out with a friend or family member. But since you might not have an available friend or family member, then you got me. All right, so let's talk about the first graph. All right, when I evaluate this first graph, I see a diagonal. And we know that a diagonal means a constant speed, right? All right, so I'm also looking at it. Is it very steep or not very steep? I think it's kind of steep, right? So I'm going to write down a note about this. Make this a little bit bigger, right? And I'm going to say for the first one, fast constant. All right. And then I'm going to come back and look at it again. And, oh, wait a minute. I see a horizontal, right? So if you have a horizontal on a distance over time graph, that means motion has stopped. That's right. So I'm going to take that next note, fast constant, then a stop, and then let's go back and evaluate the graph again, the last line. All right, it's a constant speed, right? But slightly slower because it's not quite as steep. Like that'd be a scarier hill on a roller coaster, so it's because it's very steep. This one's not as steep, so he's going a little bit slower. So the way this is going, and then let's say medium constant, what you're doing is you're basically be slick and predicting, right? And now I know from evaluating my graph that I'm looking for fast constant, then a stop, and then a medium constant. So now you have to identify the story that describes the graph. Tom left his home for a run, but he was unfit and gradually came to a stop. Is that what we said? We said fast constant, stop, medium constant. Oh, wait a minute. You know, one other thing I didn't think about was here. See right here, this medium constant, right? Is he continuing or did he turn back around and come back home? Yeah, I forgot to say that. All right. Medium constant back to zero or back home. Because the home number, I always think of zero, the zero distance as home, returning back to your home time. All right, so now I forgot to think about that. This one doesn't say anything about him coming back. It just says he stopped, right? So like this would be okay right here, but it said gradually stopped, so that would be kind of curvy if he gradually stopped. All right, opposite Tom's home is a hill. Oh, wait a minute. Am I just trying to confuse you? Are these graphs about going up a hill? Ever? Ever? Do I need to read any more? Now say no, because if they're asking you if he's going up a hill, it says Tom climbed slowly up the hill and then walked across the top and then down the hill. That's literally not what this graph is about. It's about distance and time. All right, what about this? Tom ran from his home to the bus stop and waited. He ran, right? A fast constant. Here's the bus stop, and then he waited. And the next one said he realized he missed the bus, so he walked home. All right, then he went home. It was a slower constant. To me, that matches with what we said. Fast constant, stop, and then medium constant back to zero. Because it said he ran from his home, stopped and waited, and then returned home at a walk. And this says after the party, Tom walked slowly all the way home. That wouldn't work because it's forgetting about this line and this line, the fast constant, then the stop. So now the only one that it can be is, all right, you got it. All right, next one says, find the story that matches the graph. All right, I see all kinds of curvy lines. So when I look at this, I see lots of acceleration, gradually changing speed. All right, but it does look like at first, right, that he's gradually getting faster, right? So let's go back and say that. Gradually getting faster. All right, and then let's go back and see. All right, gradually faster, and then it's kind of gradually slowing down and then gradually fast again. gradually slower, then gradually fast again. Gradually means just a little at a time. And this person does not return home in this one, right? They just keep going further away from home. See how it goes like that? All right, this says Tom went out for a walk with some friends. He suddenly realized that he left his wallet behind, so he ran back home. Did Tom go back home in this one? It seems to me he just keeps going further and further away from home. All right, next. Tom walked to the store at the end of his street, brought a newspaper, and then ran all the way back. Does this graph show him coming back? Remember, it would have to come back down like this. All right, the next one says, this graph is just plain wrong. How can Tom be in two places at once? Well, here's what this means. If you have this kind of line like this in your graph, straight up vertical, that's literally impossible. And the reason that that's impossible is because you have distance increasing, like from 3 to 4 distance, but you don't have any time increasing. You see what I mean? So this would be like 1, 2, 3, 4 seconds, and the distance increased, but no time passed. And that's impossible, right? This shows that absolutely no time passed as he moved, and time is always tick-tocking. So on a distance over time graph, a vertical line is just impossibility. So I don't see a vertical line on that graph, so I'm going to think that that's not right. Let's see this. Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground and then speeded up again. Is that what we said? Go back and double check what I wrote. Gradually faster, gradually slower, gradually fast again. Seems like we maybe found our right answer for that one. All right, let's go to the next one. Ooh, now. All right, I think we might know it, right? Because look, I showed you how having that kind of part in your graph means that you're staying, you're moving, but no time is passing. And you can't move without time passing. Time's always passing, right? So this is just impossible. So this one leads us back to the one we skipped before. This graph is just plain wrong because it shows that Tom is in two different locations at exactly the same time. Two different distances from home all in the same time. It's impossible. All right, we're going to go on to the next one. Find the story that matches the graph. All right, so now I see this diagonal. So that means the speed is constant, right? So I'm going to first write down constant speed. All right, now the other thing to notice about that graph is that the diagonal starts, right, at 0 time, but far away in distance, and comes back home to 0 distance. The 0 distance line is right here. See right here? It comes back to 0 distance. So after the party, Tom walked at a medium speed all the way home. So I would think here's the party and Tom's going at a medium speed all the way home. Right, this one says Tom walked slowly along the road, stopped to look at his watch, realized he was late, and then started running. So could that work? He walked slowly and then stopped. No, because if you had a stop, then that would mean that you had a horizontal line, right? A horizontal. Right, next one. Tom ran from his home to the bus stop and waited. He realized that he missed the bus, so he walked home. Oh, okay, that's not right because that's one we had before where it was like this, and then like that. Tom's home is on a hill. We can stop right there. So now I think we should know Tom was going at a medium speed, right? All the way back to the starting place. All right, find the story that matches the graph. Look at this one. I see a constant, but first it's a slow constant. Returning home. Okay, I'm just going back to write this down. So the first one, the second one, the third one, I'm writing impossible. The fourth one, good, and then the fifth one. which is where we are now. What did I say? First it was slow constant. Yeah, so slow constant at first. Slow constant. All right, and then next, let's look at it. All right, and so this one says, okay, oh, then wait a minute. Then it gets a little faster constant, then even faster. So let's write that down. Faster constant. And then even faster constant. All right, so now let's see which one matches the best. All right, Tom walked at a slow constant speed from his house. He increased his speed, then increased his speed again. Look. Slow constant, faster constant, even faster constant. This one says after the party he walked slowly all the way home. That would be that one, right? Tom left his home for a run, but he was unfit and gradually came to a stop. That one would look more like this. Just like that. He ran real hard and then realized that he was too lazy and too out of shape and he stopped. All right, so I don't think that one would be right. And then the next one is Tom ran from his home to the bus stop. See, we did that one already. That's the one that was up at the top. The bus stop one right there. All right, so there's only one thing that it could possibly be. All right, and thank you for watching my video. I know it will help you do much better and have an easier time on your Google form. Love ya. Mean it. Mwah.